Graphing systems of linear inequalities is really just graphing multiple lines. We just have to remember to consider when are the lines solid, when are they dashed, and which direction do we shade based on the symbol. So in example A, this one only has y. So this is hoi, this is a horizontal line at 3. We need to think about if this should be a solid line or a dashed line. What do you think?
Solid.
This symbol gives us a solid line.
Sure.
Then we have to think about shading. The y is what we want to shade. We want to shade the stuff that is smaller than 3. So we need to shade down. So I'm going to lightly shade down this direction. The next inequality, x is greater than -2. This is VUX. This is a vertical line at -2. It's greater than, so do we do solid or dashed?
Dashed.
Dashed line.
To the right.
We want the x values that are larger than -2, so -1, 0, 1. We need to shade to the right. You need to look for the area that is double shaded, and that is your final solution area. So I like to use a highlighter up here because it makes it easier to see where that double shaded region is. I would just shade each region super, super light, and then once you see where the two regions overlap, shade that region a little bit darker. Okay, now I have a question for you. This might be a little bit redundant, but I am going to put some points on this graph. You don't have to put the points on your graph. You just need to kind of look at these and make decisions. Okay, point A. Is point A a solution to the system? It is not.
Correct.
It is a solution to our second inequality, but it is not a solution to both inequalities. Okay? Point B.
Yes.
Point B definitely is a solution. It's in the double shaded region. How about point C?
Yes.
Point C, yes. Notice it's on the solid line, which means it's included in the shading for that region.
Uh-oh.
How about point D?
No.
Why no?
Because it's a dash.
It's on the dash line. If you're on the dash line, you're not included in the shading. It's everything up to that line, but not including that line. Okay, do we need to do example B, or do you feel like we're good on this? Okay. On example 2, we are going to have to rearrange these inequalities to get them to look like y equals mx plus b so that we can graph them. So let's look at this first one. 2x minus y is less than or equal to 5. First thing we would need to do is subtract the 2x on both sides. That will give us -y is less than or equal to -2x plus 5. What do we then need to do to get rid of that negative in front of the y?
5 by 1, -1.
And when we divide by a negative, what's going to happen to this inequality symbol?
We gotta flip it.
So y is greater than or equal to positive 2x minus 5. And I'm going to highlight that inequality symbol so you can see dividing by that negative flips the inequality symbol. Okay, let's graph that one. We are starting at -5. Now, some of you can graph these in your sleep, and you feel like this is just so boring because you're really, really good at this. But there are still some of you that are trying to put that -5 on the x-axis. You do not start on the x-axis. You always start up or down on the y-axis. Our slope is 2. That means up to right 1, up to right 1, and so on. Okay, once we get the line dotted, do we need to fill this in with a solid line or a dashed line?
Dash. Solid.
Just solid?
Solid.
Solid. Solid line.
So do not. Oh, okay. No.
Okay. Now, shading. Shading on slanted lines can be a little bit difficult. I don't want you to think about left, right, up, down so much. I want you to think about 2x minus 5 is the line. Our y values that we shade need to be bigger than that line. So if you put your pencil on the line, like I'm going to put my pencil at -5 on the y-axis. If I put my pencil right there on that line, where are my y values bigger than -5?
Left.
-4, -3, -2, they'd be bigger this way.
Sorry.
So yes, that's up, but it's up and to the left, because when you have a slanted line, it's not really so easy as just up or down. It can be kind of hard to see. So we'll shade this area of the graph. Next, we need to get the second inequality ready to graph. We have x plus 3y is greater than 15. Subtract x. And then divide by 3. When we divide by 3, do we flip the sign?
No.
No. Negative x over 3 is -1/3 x. So this is the one we're actually graphing. Start at 5 on the y-axis. Okay, again, some of you are going to look at me and totally roll your eyes, but some of you need to hear this. When your slope is negative, only use the negative once. If you go down 1, you've used your negative, you then move right 3. If you went up 1, you haven't used the negative, so then you'd need to go left 3 to use the negative once. Only use the negative once. If you move down and left, you've done negative, negative, which is actually positive, and you want a negative slope. Okay, does this one need to be solid or dashed?
Dash.
Dashed. And we need to shade greater than. So if I put my pencil on the 5, 6, 7, 8, that's greater than. So we're going to shade this upper part, which means our final solution area is this upper left chunk of the graph.
Go.
All right, let's move to example 3. There we go. I want you to try example 3 on your own. Yes, there are 3 inequalities, but I believe in you. You can totally do this. Rearrange the first inequality. Don't forget your rules. The second 2 are either horizontal or vertical. Get all of these graphed on the graph. Okay, so this first one, we would need to subtract x on both sides, so -y is less than -x plus 2. We'd divide by -1, and that would give us y is greater than positive x minus 2. So we start at -2 on the y-axis, a slope of 1, and this is going to be a dashed line. And it's shaded up. I think I'm going to use highlighter on this one. So that's all of this area. Okay. Then, I don't think I want to use purple. X is greater than -2. That's a vertical line. Dashed line. So dashed vertical line at -2. Hopefully your dashes aren't quite so messy as mine. And we need to shade greater than, that would be all of the numbers to the right. Then y is less than or equal to 3. That is a solid line, solid horizontal line at 3. And we would shade down. We've basically shaded in the entire picture. Where is the final solution area? In
The middle.
in this little triangle. Now, if we were really making a fancy version of this, we would delete all of the extra shading to leave just the final shaded area. But if you do have that extra stuff around, just make sure you shade super, super light. And then your final solution area, shade that nice and dark.